So I use Absolute Manage at my job currently. They don't have something like this already. All they really have is something, a package that you can deploy that enrolls in Absolute Manage. But say if you want something that adds a user and does other things right off the bat. So we're going to go through making something like that. Okay, so first thing we need when we do this, well, let's just define what we want the package to do. First, let's have the package name the machine, followed by some naming syntax that we define. We're going to go ahead and create a management account, an admin user, or admin users, whatever you want. We're going to set up SSH and ARD access for those admin users so we can get at the machine remotely. Finally, we're going to roll it into the management platform, which is as simple as basically having our package call another package, whether it be Casper or Monkey or Absolute Manage, to enroll it into that management platform that you guys have, and then make the package available to the user. So the first thing that we need is a plist to define what our package is going to do. It's going to change for every institution that you run it at, or wherever you're going to be running this package. So this is a nice, easy way to format some data that a package along with the Python script can read, and then make basically users and different types of decisions based on that. So this is just the standard structure that I put together that will write a script that interprets and makes decisions based on this. These is done, you can ignore. It's part of a larger application suite that basically manages kind of a whole light touch deployment on the Mac. We're just going to focus just on the Casper kind of creation of this. So we have an admin's dictionary here that contains really as many items as we want. And we're going to define a couple things that you need. You need a real name and a short name. Is it a super admin? That's actually, we can ignore for now too. That's a part of another talk. And then we need a hash, which is basically the password. What do we want the password to be? And this part gets really fun when we're able to basically pass in this one-way hash, but have OS X understand it. And when the user goes to type in their password, or you go to type in your password for this admin account, OS X will know what you're looking at. And you're not passing in a clear text through the script or through this plist. And then for fun, we'll go ahead and put in a picture there, so all your admin accounts have the same picture if you want that. We also need to, this will make sense as we go through the script, but the computer name prefix, we can basically have a prefix for the computer name, whatever we want it to be, as well as the asset tag if we wanted to name a machine based on a serial number or a MAC address or whatever else you want to do to name the machine. And we can get this dynamically, but for this purpose we're just going to have a static value. Some other information that you can pass in, like the group name, if you have groups in Absolute Manage or in Monkey that you wanted to pass in, and basically when this machine runs this package, it'll automatically be in the proper group that you define. So let's go ahead and get started. We obviously need a script to do all this. There's not really anything out there right now that you can just plug in and it'll do exactly what Casper does without buying Casper. So we have to have a script to define all this. And the script is kind of long, but we'll go through it. We also need our management platform installer. So here's what Absolute Manage is agent installer looks like. And for this purpose, we're just going to use a wiki to host the final project. You can use any type of service you want, email the user the package, set up a web server, but OS X Wiki is nice because you can restrict it to certain AD groups or LDAP groups and only have certain users log in and see certain wikis that have different versions of the package on there for you. Okay, so we already went over the plist data. Number 2, the script. So like in the first session, we went over defining our methods our modules that we'll be using in Python. And I know it's kind of hard to read, so we'll have all this up on GitHub for you guys to read later on, but we're going to go over hit the main points. Hint, we're looking at the binary format for the plist again, so we'll obviously be doing something with binary plists. And it was pointed out in last session that direct plist manipulation is not promised to be supported in the future. So there's things like cfprefsd that have APIs that we can look into. For this example, we're not going through that. We're just going into the native plist configuration like we have been for the past 10 OSs. All right, so here's the main for this script that we're going to be going over. Like we talked about in the last session, the main is kind of what drives the program. It pulls in the data, it goes ahead and runs other functions that do certain things for you. So our main's pretty large, but it's not that bad. Half of it is basically taken up by reading a plist and parsing it. So there's only really 4 major things that this does. It sets up logging so we can figure out after the fact what this thing actually did. In Python, it's really easy to set up logging. There's a logging module you can import, and you just define what, actually we go over this, so it's a little bigger in a minute. So we'll go do this now. So this is a simple way to set up logging instead of just printing out the status of the script. Since you're not running it directly right in front of you, it's going to be run by a user. You want to go ahead and look at a log file later on. You don't want to parse through the whole install log file to find the right date that the user ran this thing. So we're going to create a log file, stick it in var log, name it whatever you need to name it. And this is just a standard way to make the log file look, give you the right information, the date and time. You can manipulate any of these parameters to flip them around or however you like. I like the way that this looks. It gives you the date and then the time and then whatever the message is that you want to impart. So basically, starting off in the script in the main, we go ahead and say we're starting the script and we're going to start importing that configuration plist we just defined. So let's go ahead and basically parse the plist that we just defined. So the plist will be installed by an installer to some place on your file system. I chose this temp folder, and we just basically have to make sure the paths match to wherever you're putting it in your package. Whatever path you're putting in your package, basically make sure it matches here. So Python for reading non-binary playlists has a great module called plistlib. And you just import it, and it's super easy. plistlib.read plist, and then give it the path, which is this string right here. And all of a sudden, this plist is actually a Python dictionary of that plist that we just had up there earlier. So then we can start doing things with it. So what we're going to do with it is assign a number of variables based on the plist. We're going to assign the asset tag to the asset tag, and so on and so on. The only thing that gets a little tricky is this admin section, because you noticed earlier the admin section is actually a dictionary. So when you assign this admins section of the plist, this is actually a dictionary. Python has type inference, so you don't really have to tell it what type of variables this is. It just knows. So when you use it later on, it acts as a dictionary does.
Just a quick question.
Mm-hmm.
If you know that, could you, or should you, maybe as a good practice, give the variable name like dict on the end so you know when you're debugging?
Yeah, you definitely could. I'm not sure as far as best practice. Like I said last class, I'm not an expert in all this. This is just kind of like my trials and tribulations of what I've been doing as a sysadmin. And there's probably people in this room that are a lot smarter than me that know a lot more about this type of stuff. So if you see something, this is more of me trying to impart what I've learned, and it may not be best practice for everyone else, but yeah, this you could definitely have admins and then underscore dict or something like that to tell you it's a dictionary. Okay, the rest of the stuff is pretty straightforward. It's basically all these are going to be strings. There's not too many crazy things going on there. This try block is basically just, it's pretty simple. It just allows us to read this plist, and if any of these things fail for whatever reason, if the plist gets corrupted, if for some reason this time zone key doesn't exist, we'll go ahead and I'll catch that error. It'll be a key error or an IO error if it can't find the file, and it'll exit and log it and basically say what the problem was. Okay, so this looks a little complicated, but we'll go over it. This is what this looks like. This plist variable right here, it's a dictionary. This is what it looks like after reading it in, and this is what it looks like in memory. So we have our whole plist here. Here it is right here. And we see all the things that we defined earlier. And the only kind of tricky thing, like I mentioned, is the admins. All the rest of this is just simple strings that we can work with. But the admins is actually, let me take back my words, it's a list of dictionaries. So it's a list that can have as many items as you want. And inside that is a dictionary that holds user information of the users that you want to be creating on the system. So in this particular example, I added to that plist and added 2 users, one called Tom, one called Jer. And this goes through and defines the passwords. If you were to take a screenshot of that and send it through a hash cracker, you define that the password is exit. Save you some time for both of these. And you can notice that these hashes are actually unique. They're different. Even though the password is the same, it's due to Apple's type of hash that they have, and we'll get into those that a little later, which is actually pretty neat. So the next part of the main is the run the functions, similar to our last class. This part, there's a lot of things that we define here that we don't know about yet, like the number of these functions, like name machine and share settings, we're going to define until and then run later through this main. So we'll come back to that. So I like this view because it shows you what's going on in memory and then what's the actual script. So basically this allows us to take a look at how we go ahead and name a machine in Python. OS X has 3 names: your computer name, localhost name, and your host name. Each one of them is important and they do different things. So you got to make sure you set all of them, and their different behaviors. You'll see if you don't name the local host name, I believe your DDNS will pick up and assign you a DDNS address, which could be totally different than what your actual name is. So setting them all right off the bat will ensure that when you bind to Active Directory or Open Directory or your DNS records, they always will stay constant. And the way we do that is by calling this scutil executable. It's built in OS X. I believe it stands for System Command Utility or System Computer Utility, something like that. And what we do is, so this is a function. So we're going to call it later in main, and it takes as input a computer name prefix and an asset tag. And luckily, we defined those earlier in our plist. So we know what asset tag is, and we know what our prefix is. And what it's going to do for us is make a new string called machine name that takes our computer name prefix, our asset tag, plus the word Mac, plus the LT or DT from this lapperDesc return value, which we'll define this method in a minute, this function in a minute. But basically, in the end, we would get a machine name similar to this. And this is just the naming convention that we have chosen. You can manipulate it however else you want. So in the end, the machine name will look like this. So for every item in this, it's not even really a list, but just for computer name, localhost name, and host name, it's going to execute this command and basically name all 3 of these the same. So our machine now has good solid names. So anything else we do, bind it to AD or enroll it in the management platform, it's going to have a good name right off the bat. It won't be like Tom's MacBook Pro, and we'll know what it is. And then we just log it and tell the log what we did. So this is a really bad way of running a script. This is a lap or desk item that we defined earlier. It will either return LT or DT based on laptop or desktop. And does anyone know what's wrong with this and why it's really bad? Not really. It's more of this command is just one long string. So as you saw earlier, it's best practice to pass in a list to the sub-process to communicate with the operating system and run executables on their file system. Basically, this is allowing 3 types of executables to run at once. We're running this system profiler, this grep, and this grep again. Basically meaning if someone could get in here and manipulate the memory of this string, they would have a nice easy way to go ahead and run a different executable with whatever access the script is running, which it'll typically run at root access. So that's obviously not good. Passing in a list defines the executable right away, and then anything after that's just a parameter of that executable. So it's a lot more secure when actually running this. So we have a better way. I actually didn't put the better way in here. I guess I left this part in here, which basically is just split this up. And we'll do finds in Python to find. Instead of these greps, we'll just do finds in Python to find if it's a book or a Mac. And that'll work. Okay, this section is pretty cool. We're going to create a user from the users that we defined there in the dictionary earlier. And it's comprised of 2 steps. First thing, we're going to do all we can with Disco. Disco is a great way to create users and set UIDs and all things like that. But it's not so great because it doesn't accept anything except for clear text passwords. And when you're dealing with sending a script to a user over the internet or distributing a package, we don't really want to put clear text passwords for admin accounts in these scripts for them to create these users. And there's lots of ways to, once you have a management platform installed, to go and set passwords, create users that it zaps down real quick and does things like Casper and then removes itself. But since we don't have any management on this machine at all, how are we going to go ahead and get this done? And we're going to use the shadow hash data field in the user plist to go ahead and accomplish this. So the very first section you've probably all seen before. There's been lots of posts about the standard commands to go ahead and create a user. We do this in the proper sub-process format of passing in a list. So the first parameter is the executable Disco, followed by all its parameters that we have afterwards. So we create a user based on the username that comes from the plist that we defined earlier. The real name, we set the picture based on the picture path that we defined earlier. We'll get to these 2 grayed out functions in a second. We set the unique ID by running this other method called unique ID, so we'll go ahead and get that later. And primary group ID is 80, so we'll make it an admin. We want the shell to be bash, NFS home directory is just going to go to the standard user place, and we'll go ahead and copy in the template, so it actually kind of similar to the create mobile account. This will basically copy in the template for us, so when the user logs in, they have the proper template already. I think it does that automatically, but we'll just put it there already. And then the last section is not with Disco at all. We call this function called write hash, and it takes as input a username and a hash. Luckily, we already have the username and we already have the hash defined in the plist, and I'm going to show you how you generate this hash and how we implement it and inject it into that newly created user record. Coming back to this 2-step in this bash command here for password, previously a way to kind of obfuscate the password and not make it clear text would be to use reversible hashes. Like this base 64 is a standard way to take a string, pass it through this base 64 hashing thing in Python here, and what it does is it gives you a standard length hash, but the problem with that, it's fully reversible just by a couple Python commands, and that's what we do here. So basically, it doesn't provide any security at all. It just eliminates someone looking over your shoulder and reading what it is. So we don't want to use that method, because if someone gets a hold of this script or if someone gets this package, we don't want them to have our admin passwords. So this is how we go ahead and create a user and assign a password using shadow hash data. It gets a little abstract, but I'm going to try to explain it as best as I can. I think there's a couple other people out there doing this. I know that the Puppet folks have something similar written in Ruby that I looked at a lot to get a lot of inspiration on how to do this in Python, but I'm not sure if there's anyone else out there that has this posted. So I'll try to go through it as best I can, and if there's any questions, just shout them out, or if there's any better answers to this problem, let me know. All right, first thing you have to do is go and flush the DS cache. I found that doing this just avoids any conflicts with passwords that are cached on the system. We give it a couple seconds to settle. Then what we do is we open the user's plist. So we just created a user. We know what that user is. User.plist will be generated for them by Discal. This is stored in var, gb, ds, local nodes, default users. It's a pretty standard, this hasn't changed in a while, this is a pretty standard place for the directory services to store its user information. This user plist is stored in a Apple binary format. So like we did in the previous Cisco example, we go ahead and read it in. So we have a bunch of data that just looks like gobbledygook. And we go ahead and buffer it. And then we pass it into the NS property list serialization class. And what that does for us is it outputs a nice clean Python dictionary. So now we have a user plist that is in a Python dictionary called user plist. The funny thing about shadow hash data is it's actually an item inside our user plist, and I'm going to give some visual examples so you can kind of visualize this a little more. But the way it's stored is it's a little tricky. It's stored as an array in a string format that is also an Apple binary plist. So the shadow hash data is in and of itself a plist that's been wrapped into a binary plist inside of a list inside of another binary plist. So it gets a little complicated, but I think I have a good way of explaining it in this next slide. So basically, we're able to go ahead and read and buffer, just like we read and buffered the Apple binary plist. We have to read and buffer the shadow hash binary plist, and then we'll have a usable Python dictionary of our shadow hash plist. And that is right here by using the same exact method as we would read a regular plist, but we're not reading a file on the file system, we're reading a string of data from the plist that we read earlier. Once we have this, there's some insecure hashes that OS X doesn't create by default, but if you were to enable SMB file sharing, it creates this NT, which is easily crackable by anyone who is familiar with cracking tools, and also this MD5 version of that password. So we want to get rid of those because we don't want to be sending them in our script. So after we get rid of them, we can convert our shadow hash back into data. So we go ahead and take that good Python plist, shoot it on over to this, and this will export it as the binary format. It looks just like gobbledygook. You can't really understand it. And we insert the new shadow hash back into the user's plist. So this shadow hash is what we defined in the plist originally that we got from at the very first screen, that clear text plist. And you can see here, there's the user plist. There's a field called user plist is here. This is the user.plist. That's what we're looking at here. There's a field or key called shadow hash data. There's a list and it's item 0. That took a while to figure out that this is actually a list. It's not just a string. It's a list that only has one item. And then what we do is assign the user shadow hash data to that item 0 in the list. Once we do that, we convert the user plist back into data, and after that we'll write it to the disk. So we just input where we want to put it, same exact spot. We're just going to go ahead and plop it right back down there. We're going to go ahead and flush the cache again, just in case there was any lingering old versions of the password, or in this case, there wouldn't be any password. This is also, you can also use this to change someone's password. Instead of using Discal, you can use direct hashes if you wanted to. So I'm going to get a little more deeper into what we just talked about and how the shadow hash data is stored, and to show you what's going on here. So shadow hash data is an Apple binary plist that is nested inside of an array, typically shown, if you were to look at it, in a hex format or an MD5 format, if you're looking at like VI or Nano of a converted user plist. And this field is wrapped inside of a user.plist that is also an Apple binary plist, which we just went over the process of taking it out of the Apple binary plist, taking the shadow hash out of the Apple binary plist, and then we can actually get what it looks like. So this right here is what all this fuss is about. This is the shadow hash data. It's comprised of a dictionary that's a plist of 3 fields. This entropy, the iterations, and the salt. These things are important for OS X to basically check your password. When you type in your password into OS X, it goes ahead and opens this up, goes ahead and runs whatever function it runs to, well, it's an SHA 512 with the tweaked FPKDF2, whatever that means, and whatever math they do for that, I'm not sure. But they use these values, which are unique to each hash, to see if you type in your password right. Basically, it generates this entropy based on what you type, based on these things, and if they're right, then you get it. So basically what we're doing is pre-generating this, packaging it up, and shooting it on into whatever machine we're going at. And then that goes in their user plist. And basically what we're doing is sending us as secure as you can get, basically, without passing a clear text password into a script to go ahead and set a user's password. Here's another look at it, and this next slide shows it pretty well. Here's the hex representation of the Apple binary plist. Here's what the gobbledygook looks like when we actually read it in. And then this is the clear text version. And this is what all the fuss is about. Does this make sense, or did I totally lose you guys? It's kind of hard to articulate, but essentially what we're doing is getting rid of clear text passwords and scripts and allowing OS X to allowing us to pass in a mechanism to OS X that it knows what our password is, but no one else would know except for OS X what this password would be. Password crackers, they do have support for this type of hash. It takes a very long time, and if you have over 8 characters, it's a pretty darn secure hash, and it would take a long time to crack it. Wow.
I have a question.
Yeah.
So you said that we're generating this information from the hash that we passed into the plist?
Yes.
Where does that hash come from?
I'm going to show you in a minute.
Oh,
Yep.
the original one.
The original one.
Okay.
So there's a set of tools that I wrote to do this, to generate this hash for us, because Apple's pretty close box about how they generate it. So we use OS X to generate this, extract it, and then pass it in, and then put it in another system, and then you're good to go. just some notes about kind of like what I explained as far as how OS X is checking and why this actually works to type in your password and what OS X is doing to verify that you typed in the right password. So this is the clear text version. This is the Apple binary version, and then this is the hexadecimal version. This is really easy to work with. We're able to put this in a plist because all it is just a hexadecimal number. So it's 0 through 10 and A through F. So that's really easy to pass in as a string, and then we can have Python, like we did earlier, do the rest and unwrap it and put it back in its proper format. So this is the format that I like to use to actually put in the plist and send to machines, because it's easily usable and it requires a lot if someone were to get a hold of it to try and crack and extract your password. If you have a secure password, it's pretty good. So how do we get this stuff in the first place? Kind of Jeremy's question. If you go to my GitHub, there's something called shadow hash tools. There's an extractor, which basically you type in the executable, type in the password you wish, and it'll output an OS X SHA-1 generated hash, and you can use that hash and pass it into another tool that's on here, which is an injector that'll inject it into any user. And we're gonna, if we have enough time, go over those tools a little later after this is over. If not, then you can grab it online. So going back to the same list, now that we have a little more understanding what's going on, I'll just go over this to kind of hammer it home. We read in a binary plist. It becomes a Python dictionary right here. We're able to then read in the shadow hash data, which is a binary plist, from that Python dictionary. We then convert the shadow hash data from a Apple binary plist to a Python dictionary, do any removing that we need to do to make it more secure. Then we convert the hash back into data, the shadow hash data back into Apple plist data, put that in the proper place for our new user's plist dictionary, and then convert the whole, for the plist, user's plist, and then convert the whole user's plist back in the Apple binary format and shoot it down to the file system. And that's it for shadow hash data. So we'll go over a little bit at the end if we get through this in time to talk more about shadow hash data. But it's a pretty cool technique to get rid of clear text passwords and scripts. The next thing on our requirements was set up the share settings. So we also want this Casper, Casper kind of mimicking package to set our share settings. So the way we do this in Python is using the kickstart executable, as well as the system, where is it? Must be on another line, but
System setup.
Yeah, system setup. Oh, there it is. Yeah, system setup. And that basically does the SSH. So for all this is doing is this taking that list of users that we have in our plist that we defined to control the package. We can have 50 users in there if we wanted, and it would loop through every user and make them a part of the admin group if they're not already, and then turn on SSH access for only administrators, and then add them to the remote management and give them all the options. So every user that was in our plist will go ahead and get that. Next stop is I'm going to show you how to enroll into Absolute Manage. You can do this with any other management platform that you have. Absolute Manage has actually a plist for their package that defines what their package does, called defaults plist. And then you can manipulate some of their fields directly before you even enroll the machine to put it in the proper groups that you want. Excuse me. And we do that here. We pass in our group location. And this is pretty specific. This is, you know, you can manipulate this as much as you want for the type of environment that you have. And then it goes ahead and installs the agent script that will go ahead and roll this into Absolute Manage. And that is basically it. So then we can distribute it using a wiki. So we have a package now that goes ahead and names the machine, so it's going to have a nice name, creates the users, puts the share settings on, and then rolls it into whatever management platform you have, similar to what Casper does. And later on, our good friends Jeremy and Rich will be speaking on some of the similar topics that we're talking about, extending OS X systems with scripting. So they'll be going over some Python and some Bash. So if you want to learn more about scripting, go check them out later this week. Here's the URL to go ahead and get feedback. And here's my GitHub. I'll leave that up for now. And we have about 30 minutes left. So it's up to you guys. I could go more over shadow hash stuff and kind of show you some examples of how to use those tools that are up on my GitHub. Or if you have any questions, we can go over those. Sure.
So, forgive me, you probably kind of mentioned this, but it sounds like you create the hash and you pass it and stuff, and the endpoint never actually like decodes it. It just can read it as it is, right? Exactly. Yeah.
Yeah. It doesn't decode it. It just reads it as it is and puts it into the binary users plist. And then when you go to log on, OS X does the decoding and all the backend stuff to verify that you typed in your password correctly.
Why even if someone got that hash, they couldn't really do anything with it.
Yeah, well, I won't say that overall. Of course, there's some really smart people out there that can reverse hashes, one-way hashes, using GPUs and large computers to generate millions and millions of them a second to try out different words. But if you have a strong password, the chances are that this is about as secure as we're going to get it with the tools that we have. Any other questions? Okay. Well, let's have some fun with shadow hash data. So I'm going to go, hopefully the Wi-Fi still works. Actually, I have them locally. So up on GitHub, there's two guys here. One's an extract and one's an inject. And let's just read the README real quick if we can. Okay, good. So generate, manipulate, and embed shadow hash data. These scripts are standalone. They don't require us defining the machine name and all that other stuff that we just did. These will work just by themselves. So first, to basically generate a hash, but what we're really doing is extracting it. We're having OS X pass in a clear text password, and then it's going to give us the shadow hash data that was just generated for us. So to do that, go ahead and execute the script with sudo access and -p and type it in a password, or if you type in a password list, you'll get a list of 20 or so versions of the hash if you wanted to have a list of future hashes to run later in the future. So the inject hash is pretty simple. You just type in sudo inject hash, the user short name that you want, and the -p hash that we were looking at earlier. This is the hexadecimal representation of the Apple binary shadow hash data that we were looking at earlier. So it's super easy to work with. You can paste it right in a command line. You don't need to do anything fancy. And then this inject user hash will interpret the rest and put it where it needs to be. So let's run that real quick and try something a little different. Let's do this first, just make sure it works. Let's get up to root. You're seeing this, right? Yeah. Is that, can people read that? That look good? So we're going to go to where those were locally. You can just download them off GitHub though. Oh, I'm in root. And that is in. Okay, so we're here. And they're not executable, so let me make them executable. Okay, the first thing we're going to do is going to extract a hash. And we give it the P parameter, and we'll just make a password of PSU. Super insecure. And what this will do is, takes a second, kicks out a sweet shadow hash that we're able to copy and then use it on our which user? We'll use the user Tom. Now we use the inject script. I think that's a user on our system here. Yeah, Tom, standard. Cool. And his password right now is exit, like we were looking earlier. So if we type, we'll know that this hash took place if it works. So then we pass in the -p parameter, and we paste in our hash. It's just that simple. And what this does now is, underneath the hood, and you could take this hash to any 10.8 or 10.9 machine and use the same inject hash and change a password without having to ever type in a clear text password on that system, as long as you have root access. And we get a good error message, was injected. So let's just do this. We'll log in Tom, and I'm going to type in the password PSU. PSU. And there it is. It lets you in. What else could we do? I had a thought. This has to do with File Vault 2, if any of you are using File Vault 2. If we were to, yeah, let's do this. I'm going to hop on another user real quick.
Can I make a comment?
Sure.
So I actually worked with Tom, not worked on it, but we kind of played with this a little bit before and found a really cool use case for it with remote users who are bound to the directory. So not a local user where you can kind of set the password and then ship the computer out to them or something so that they're already enabled in File Vault. We got it to work, maybe that's what you were going to show.
Yeah.
We got it to work really well where we had a local computer with a mobile account, and we were able to use the hash data to authorize them to File Vault so that when we shipped it to them, we would say, hey, your password is test or something, and then again, if they're on a domain, eventually it'll just refresh and then use their real password, but that way you can enable them before it ever touches their hands. They don't have to have a local temp user or something and then do it. So there's a lot of kind of cool use cases for something like that.
Yeah. It's more hackerish, and I'm not sure if I would suggest it like in practice, but it's just kind of cool, I think. So we're in another user now. That user we were in before was a mobile networked user. We're in a standard user now. So what we're going to do is, and this machine's file vaulted. I'm going to elevate myself up to root. And I'm going to remove that user that we were just in, the mobile account user, from File Vault so it doesn't have any access. And I don't remember the commands for that. Remove. And is it user? Do you remember what the syntax is, Jeremy? User remove?
You can just pass the user in.
Really? I think it's user to remove. Maybe we'll do a help. That always seems to work. Nope. Remove. Oh, you just say user. Okay, so we're going to remove this user from having access to File Vault. Yeah, so that guy now has no access to File Vault to unlock the disk. And we'll see there, some users don't have access. Then what we'll do is, this is a mobile user. We don't know what their AD password is, but we can temporarily basically mimic or temporarily inject a password locally on this system and then use that to enable File Vault. And then what we would do is give that temporary user to the temporary password to the user, type it in first time when they boot up, and then they would be able to enter their AD credentials and the cache would be their password would be updated. We'll go through that real quick, see if it works. So let's go back to our shadow hash tools. And that's, you guys see that's okay, make it a little bigger. So let's generate a new hash for this guy, and we'll make his password Tom, nice and simple. So we got a good hash here, and we'll go ahead and inject it into our mobile user. And we'll give it the password of Tom in this hash value. Sweet. Let's test this out real quick. So I'm going to log into my mobile user using a spoofed kind of password of TOM, and I'll let you in. So let's see if that we can now enable File Vault for that user. So FD setup. Is it add? Oh. User to add. And then we'll do that. First of all, we have to let the guy in the door and actually start manipulating the shadow the File Vault stuff. So I'll type in this admin's password because it has access to File Vault. And now it wants to enter the password for a mobile account. Typically, you would have to have the user who knows their password here to enter this in, but since we spoofed it, we can go ahead and put TOM. It verifies it locally, so we're not connected to AD. And now, oh yeah, that's true. But we'll just show this here. Oh, it's not there. Our guy has access using a network account that we basically spoofed. So next time I log in, if I get on the network directory, it's going to go ahead and balk at me and say, okay, you need to enter a real password. Enter a real password, and the DS tools in OS X will take over, rewrite the good hash to the mobile account, and then everything's good to go. So that's all I really have. We have about 25 minutes. If anyone has any questions or anything else to share, we've got an open floor. If not, oh yeah. GitHub. Github. /t Burgin. I have a bunch of stuff on here, but that shadow hash data stuff's pretty fun. So just go into repositories, and it's a ways back right here. And have fun with that. All right, that's it.